Here is a sheet which you may always need for proving trigonometric identities. Here I have 4 different types of identities. In the following videos I am going to prove these identities by themselves, okay? But have a look at it. Reciprocal identities, Pythagorean identities, quotient identities, and reflection identities. These are the 4 basic trigonometric identities which we use to prove trigonometric identities, okay? So let's look into them one by one. First one, reciprocal identities. So we know there are 3 primary trigonometric ratios, and these are sine, cosine, and tangent, right? And you also know SOHCAHTOA, right? So SOHCAHTOA you use to figure out what is sine, what is cosine, and what is tangent, right? For sine, you write sine is opposite over hypotenuse, and for cos, you write cos is adjacent over hypotenuse, and for tan, you write tan is opposite over adjacent, right? Remember, in trigonometry, S, C, and T are always lowercase, okay? Don't put them uppercase. It doesn't really look correct, okay? And it is not correct. So always write your trigonometric ratios with lowercase. Now, so that is sine. So what happens to cosecant? Cosecant, written as CSC, will be not opposite over hypotenuse, but hypotenuse over opposite. Similarly, secant is hypotenuse over adjacent, and cotangent is adjacent over opposite. So that is the way to remember, and here are 3 of them. So this is a relation of all the 6 trigonometric ratios, correct? Primary with their reciprocals. So that is how you get your 6 trigonometric ratios. At times you are asked only about primary, at times about their reciprocals, correct? So that reminds you of this. Now the second set of identities here is Pythagorean identities. I will prove these identities using a right triangle, and that gives them the name. So the way to you prove it is, in a right triangle. Let me first draw a triangle for you and then explain you the thing, right? Let's say this is our coordinate system, and in this coordinate system I'll make a right triangle like this, correct? And let us say this is A, B, and C, the 3 sides. Then I will prove this by using a simple Pythagorean, the basic ratio, which is a square plus b square equals to c square, right? If I divide everything by c square, which is the hypotenuse, you can see I get a over c. A over c is cosine theta, b over c is sine theta, and c over c will be 1, right? C squares. So you'll get sine square theta plus cos square theta equals to 1. So it's that simple to prove, right? So, but they are so incredibly useful, you'll really love them. So Pythagorean identities are sine square theta plus cos square theta equals to 1, tan square theta plus 1 equals to secant square theta, cotangent square theta plus 1 is cosecant square theta, right? The very first one is most useful, and the reason is that whenever you're trying to prove identities, convert all trigonometric identities in terms of sine and cosine, right? And then things become simpler. Even tangent, write it sine over cosine and then do it, okay? Don't worry about the fraction part there. Now the first one can be rearranged. Sine square theta could be written as 1 minus cos square theta, or cos square theta can be written as 1 minus sine square theta. So these are very useful Pythagorean identities. Now we have got quotient identities. Tan theta is sine over cos. Similarly, cotangent theta, which is reciprocal of tan, will be cos over sine, correct? And then we have reflection identities. Now what it really means by reflection identities. So in reflection identities, what happens is, let us assume that we have 2 triangles, right? So one triangle is here and the other one is reflected. Okay, let me reflect this one, okay? Now reflection identities you will understand in a minute. So what I will do here is show you. Normally theta is taken as an angle from x-axis going counterclockwise. That is your theta, right? But in case you go counterclockwise, right, then it becomes minus theta. That is minus theta, going counterclockwise, right? For the same angle, you can see in this figure that sine of minus theta, these two triangles are congruent, correct? They're exactly same, except for, y value is negative here and y value is positive there. X value remains same and hypotenuse is always considered positive. Remember that. It's kind of radius of a circle. So hypotenuse is always considered positive. However, this is x and y axis, right? So in x and y axis, if you go down, then it's negative. If you're going up, it's positive, right? So this is quadrant 1 for you, and that is quadrant 4. Let me write 2 and 3 also here, right? Now you will see that sine becomes negative, right, in this quadrant. And cast rule also, that also may help you to figure it out what I'm really trying to say, right? So let me write down the cast rule for you here so that things become more simpler. So cos is positive here, therefore cos of minus theta is positive cos theta, but others, sine and tangent, are negative. So sine of minus theta is minus sine theta and tan of minus theta is minus tan theta, correct? So try to remember this, and these are the 4 basic identities which will help you to prove the identities, okay? Now in the following videos I will go and prove them myself for you. I want you to remember them before you even start solving or proving identities. I hope you appreciate it and you get the concept of proving identities, and I'm sure you will enjoy this section of mine. This is probably my best section. Thank you.